Hello students, in this section we'll be covering the theorem for basic proportionality and the proof related to that theorem. So anytime you write a theorem, the first thing that you need to write is what is given. So all of you can copy this from whatever is given in your textbook. Now here we have a diagram. I'll be referring to the diagram from the textbook so that none of you have a problem. So here I have A, P, Q, B and C. Now we need to prove that AP divided by PB is equal to AQ divided by QC. Now, as we learned in our class before, that in order to solve this, we need to make a construction first. So the construction always will come before the proof. So this is construction. Now there are two constructions that are involved. One is joining BQ and PC. So I'll be joining these two by dashed line. As I said in the previous section that construction has to be drawn with dashed line. So here I write join PQ and BC. This is my first construction, and the second construction will be draw height to AP and AQ at points D, E. So I'll be drawing these heights with colors. So here I have the first height. Again, it's a construction, so I need to draw a dashed line. This is 90 degrees, and similarly for this triangle I have this as 90 degrees. Now coming to our proof. So as you've learned before that we need to use ratio of areas of two triangles in order to solve basic proportionality theorem, or rather in order to prove basic proportionality theorem. So for the first case I'm going to take triangle APQ, or rather area of triangle APQ divided by area of triangle PQB. Now in this case what I am assuming is that AP is my base for triangle APQ, and for PQB my base is going to be PB. So in case 1, AP is equals to base for triangle APQ and PB is equals to base for triangle PQB. Now anything that I write in brackets is not needed to be written in your proofs. This is just so that you understand this particular proof easily. Now back to our formula. So area of any triangle is given by base into height, or rather ratio of areas of two triangles is given by base into height of triangle 1 divided by base into height of triangle 2. So here we have the bases. Now coming back to our height. So as we can see, this point is D, this point is E. QD is going to be height for AP and for PB as well. So I can simply write here QD, and in the denominator I can write QD. So QD and QD cancels out, and what I'm left with is area of triangle APQ, or let me write this below. Area of triangle APQ divided by area of triangle PQB is equals to AP divided by PB. This is my equation number 1. Now similarly I'm going to take a second case. In this I'm going to take two triangles, area of triangle APQ, and now as I took PQB in the first condition, I am going to take PQC in the second condition, area of triangle PQC. Now here again I'm going to assume that the base is AQ, and for triangle PQC, the base is going to be QC into, I'll write down here, AQ is equals to base of triangle APQ, comma, QC is equals to base of triangle PQC. And now in this case, the height to triangle APQ can be called as PE, and height for triangle PQC can also be called PE. The reason we are assuming PE is so that some values can be cancelled from the numerator and the denominator. If I take QD, height for area of triangle APQ, the PE in the denominator will not cancel out, and I'll have an extra term to solve. And as you have learned earlier, that the less number of variables allows us to solve the equation or any type of questions much easily. So here again, P and P is cancelled, so I'm left with AQ divided by QC. So my second equation can be stated as area of triangle APQ divided by area of triangle PQC is equals to AQ divided by QC. This is my equation number 2. Now coming to our third condition. So now I'm going to take area of triangle PQB divided by area of triangle PQC. Now in this case, I'm going to say PQ is equals to base for both triangles. The reason I'm saying that is so that PQ can cancel out for both triangles, and because PQ is the base, that implies height is also going to be equal for both triangles. So here I have common base and I have equal height. So I can simply write this ratio as PQ into H divided by again PQ into H, which is equals to 1. So I can safely write area of triangle PQB divided by area of triangle PQC is equals to 1. So this implies area of triangle PQB is equals to area of triangle PQC. This is my equation number 3. Now once I get this, I'm going to come back to my equation number 2. Both my equations number 1 and equation number 2. So for equation number 1 and equation number 2, I can say that area of triangle APQ divided by area of triangle PQB is going to be equal to area of triangle APQ divided by area of triangle PQC, because from equation number 3, area of triangle PQC is equals to area of triangle PQB. So that means these two ratios are equal. So now from 1 and 2, I can simply write APQ divided by triangle area of APQ divided by area of PQB as AP divided by PB is equals to AQ divided by QC. And this is what we had to prove, and therefore here we have proved our required theorem. Now moving to our converse of basic proportionality theorem. Again, you have to write what is given and you have to write what you have to prove. So we have to prove that line L is parallel to BC. Here we have our diagram. This is P, this is Q, this is line L, this is A, this is B, and this is C. Now again we have to do a construction over here. So I'm going to draw PF, So this is my construction. So now here comes my proof. So it is given to us that AP divided by PB is equals to AQ divided by QC. So now before we start our proof, we're going to assume that PQ is not parallel. Line L, that L is not parallel to BC. So if L is not parallel to BC, this means that there must be a line, parallel to BC. So if there must be a line parallel to BC, so I'm going to assume that PF is parallel to BC. So if PF is parallel to BC, I can use basic proportionality theorem. And I can write AP divided by PB is equals to AF divided by FC. So now I have AP divided by PB is equals to AF divided by FC. But it is given to me that AP by PB is equals to AQ by QC. So if we see result number 1 and result number 2, we can say that AF divided by FC it has to be equal to AQ divided by QC. So in order for this to happen, F comma Q have to be at the same point. So if F and Q are at the same point, this result is going to be valid. But as we can see in our diagram that F is not at point Q, F is a completely different point, which means that F is not coinciding with Q. This implies our assumption is incorrect, and therefore only line L, which is PQ, or line L can be parallel to side BC, and hence we have proved our theorem. So you have to write hence proved after you prove this, and this is how you can write your solution. Now one thing that you need to make sure you write here, for this to be valid, F comma Q have to be at the same point. Now this is the proof that is related to basic proportionality theorem and converse of basic proportionality theorem, and this is how you have to write. Make sure that all of you write what is given in the question, because if you do not write what is given in the question, you will not be receiving any marks for that particular part of the solution. I hope this section was helpful for you. We'll continue with our next theorem proofs in the next video section. Thank you.